Hello students, welcome to this session. We are again here for the new concept which is functions over here. We will study definition of function, we will study different important forms and different important functions. We will also study domain and range. This is actually not a study center right now, this is a interaction between us. So you have to be interactive and I would give you some basic concepts to understand, and then when you will be able to go through it in detail, then you will be able to match the concept with what you will be going through it, because it is a small session, you can't study everything right here. So we will start with something very important, that is definition of function. So definition of function is actually, it is a relation, and if we talk about a relation, it is a particular type of relation. Which type of relation it is? If we map from set A to set B, this is A set, this is B set, and the mapping is such that each element of set A is mapped to unique element of set B. What does it mean? That each element of set A is mapped to unique element of set B. It means that for set A, you have only one available mapping in set B. That means you can't have two images, you will always have one image. For example, if I take an image like this is 1 and its image is A. So you can't take another image of 1. You can't say that there is another image called B which is an image of 1. Similarly, all the points in set A has to be mapped, because each element is having unique mapping. So if you are mapping 2 to B and 3 to C, then you can't leave 4 here. You have to map this one also with something. So you can either map it with B or you can map it with something else also. So there is no issue while mapping like this, because each element in set A has unique image in set B. This is having a unique image, 1 has a unique image A, 2 has a unique image B, 3 has a unique image C, and 4 is a unique image B again. So what you have to understand basically is that basically we have the elements over here, and you can take different cases. For example, I am taking a case over here where I am mapping this one to this one to this one to this one to this. Now I ask you whether it is a function or not. So you will say this is not a function. Why would you say it is not a function? Because there is an element in set A which is mapped to none of the elements in set B. This last element in set A is mapped to none of the element in set B. So this is not a function. This element has been left alone. If you take a function like this, if you take a relation like this from A to B, that this is mapped to this is mapped to this is mapped to this is mapped to this. So is this a function or not? So you will say that since this element is having two distinct images, then it is not a function. Why it is not a function? Because there is two distinct image of this element from set A to set B. If I take you to another example, that example is saying that there is an element here, here, here like this, and there are elements like this. This is mapped to this one, this is mapped to this one, this is mapped to this one, and this is mapped to this one. Is this a function? Yes, it is a function, because each element in set A is mapped to unique element in set B. This is mapped to unique one, this is mapped to unique, this is mapped to unique, this is mapped to unique. So what thing you have to remember actually, that the arrow can go like this, this, it is fine, it is a function, but the arrow cannot go like this, that this and this is not a function. So if it is converging like this, multiple elements can have same image, that there is no issue with that, but multiple images cannot come out of a same element. So that would not be a function. So this is a function. Now if we talk about another case like this, here what am I doing? I'm mapping to this one, I'm mapping to this one, mapping to this one, and mapping to this one. Is this a function or not? So yes, it is also a function. Now you will say that in set B there is one element which is not a image of any element of set A. That is fine. The set B may not have any element whose image is in set B. It may be possible. So this element over here is not an image of any element in set A. That is fine. Still it is a function, because the constraint is not on set B, the constraint is on set A. Set A may say from set A nothing should be left, but from set B something can be left, there is no issue with that. So if there is something left in set B, still it is a function, but if it is left from set A, then it is not a function. So this is how we understand function. Now there is an example to understand it. I am giving you a relationship, real life relationship I am talking about, and you know that real life relationship are many among us. First of all, let us talk about brother sister relationship. So if we talk about brother sister relationship, what will happen? That a brother or a boy can have one sister, can have more than one sister, and a boy can not have a sister at all. Both the things are possible. So mother sister relationship, brother sister relationship is not a function, because it may be possible that there is a brother and there are two sisters of this brother. So the concept that each element has a unique image will be get violated. But in another case, if we take that, suppose there is a brother and if it does not have any sister, so there are many persons who have not have any sister, so that in that case also it will violate the concept of functions. So this is not a function. Brother sister relationship not a function, because each element of set A is not uniquely mapped to each element of set B. Actually a brother can have multiple sisters or a brother can have no sister, but we can't take those cases in a function. Can you tell me what relationship is there which is a function? So if you talk about a relationship which is a function, the very important relationship is child mother relationship. That child mother relationship says that for every child there is a unique mother. So this is actually true, because if we have a child in set A and mother in set B, then each child is having a unique mother. They can't be multiple mothers of the single person. A person can have only unique mother. Similarly, there is no child, no one whose mother is not there. Okay, there is no child is without mother. Everyone is born with a mother. So there is some mother for every child. So this is actually satisfying the function concept. So child mother relationship. It may be possible that multiple childs can have the same mother. So that is not a flaw. That does not make it a non-function. Why it does not make it a non-function? Because we know that this type of arrow is acceptable, but the arrow which is this one is not acceptable. So this type of arrow is acceptable. Multiple persons can have the same mother. Similarly, there can be a woman who is not a mother of any child. That is also fine. That in set B there may be woman who does not have any child. So in that case also it is about set B. It is not about set A, not about child, but it is about mother. So the constraint has to be on child, but it is not on mother. So still it is a function. So child mother relationship is a function where child is the set A and mother is the set B, whereas brother sister relationship is not a function. So it is a very important example which helps us to understand the concept of function. Now we come to some important functions we come across. First of all, we talk about a function which is a algebraic function y is equal to x square, and this is a function whose graph is something like this. It is an upward opening parabola. Y is equal to x square. If you take x is equal to 1, you will get 1. If you take x is equal to 2, you will get 4. If you get x is equal to minus 1, you get 1. If you get x is equal to minus 2, you get 4. So actually there is a square which is happening. So this is a curve which is coming out, y is equal to x square. So now you can see here that is this a function. So each element in set A, here the set A is your x axis and set B is your y axis. So each element in set A has a unique image in set B. Why unique image in set B? Because if you input 1, you get 1. If you input 2, you get 4. There are not multiple outputs. There is only single output. So it is a function. But if we draw the graph for y square is equal to x, then the graph would be right opening parabola like this. And you can check this also by putting some values. For example, if you take x is equal to 1, then y square will be 1. Then what would be y? Y would be either 1 or minus 1 both, because 1 square is also 1, minus 1 square is also 1. So you will get 1 as well as minus 1. If you take 2, you will get x is equal to 2 root 2 or minus root 2. So as you see here clearly that this is a right opening parabola, and in this right opening parabola for every element in set A, or actually you can say that for many elements in set A, you have multiple images in set B, because for 1 you are getting 2 images, 1 and minus 1. For 2 you are getting 2 images, root 2 and minus root 2. So this is not a function. So you will say that this is not a function, and this above one is a function. So another way is to check whether a function is there or not. We can draw the graph, and after drawing the graph we will draw a line parallel to x axis, parallel to y axis. So if we draw a line parallel to y axis like this, it is intersecting at only one point. Here it is intersecting at only one point. Similarly, here it is intersecting at only one point. Then it is a function. Here if we draw a line parallel to y-axis, it is intersecting it at 2 points. So it is not a function. It can't intersect at 2 points. So still is, that is why it is not a function. So if I draw few graphs before you, like this graph is there, another graph is this one, another graph is this one. Random graphs I am drawing just to check whether you caught the concept of a function or not. So this is another graph. So whether they are functions or not. So we will simply say that let us draw a line parallel to y-axis in all such cases. So here whether you draw a line parallel to y-axis at any point, you will see that it is intersecting the graph at only one single point, here, 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 here. So it is a function. If you draw a line parallel to y-axis, it is intersecting it at 2 times here also, here also. So it is not a function. If you take a line parallel to y-axis here, it is only intersecting once. If you take a parallel line to y-axis here, is it intersecting once or twice? So just see here, we have not included this point. There is an open circle here, and we have included this point. This is a closed circle here. So you are taking a dot. So it is included. Here it is open circle, it is not included. So when this line will intersect, this will not include this open circle, this will include this closed circle. So you are getting a unique image. Similarly, if you take a line here, this line will include this point but will not include this point, as it is an open circle. So still it is a function. So it is a function. If you talk about here, these lines, these all lines are intersecting the graph at only one point. So it is a function. So out of these 4 graphs, 3 graphs are function and 1 is not a function, simply because the line parallel to y-axis is intersecting in case of function at only one point anywhere, whereas in a non-function it is intersecting at some time more than one point. Now if we take the previous example, y square is equal to x. So let us do some interesting work with that y square is equal to x. So y square is equal to x will give you two different situations. If you remove a square from here, you will get y is equal to square root of x, or you get y is equal to minus square root of x. Two different situations as you are removing a square. So actually the graph which we had drawn for y square is equal to x for this function was a right opening parabola. Now if you take y square, y is equal to root x case, then it simply means that we are taking this part of the parabola. And if we take another function y is equal to minus root x, then it is taking this part of the parabola. In both the cases, x is greater than equal to 0. So in both the cases, we see that there are two parts. One part is y is equal to square root of x, another one is y is equal to minus square root of x. So if we separately draw them, we say that one function is y is equal to root x, where x is greater than equal to 0, then the graph would be something like this, the square root graph. And if we say that y is equal to minus square root of x, and the graph is like this one, where x is greater than equal to 0 here also. So this is also a function and that is also a function. As you can clearly see that the lines are intersecting at only one point and the lines are only intersecting at one point. So individually these two are functions, but when you combine them, this is not a function. So you can make two functions out of a given relationship like this. Now we take domain. As we have studied right now, the function here, as you have seen a little while ago, this was a function y equal to x square, upward opening parabola. So y equal to x square example we are taking, and this parabola is upward opening parabola. What is its domain? Domain is basically the values of x for which the function is defined. So domain is values of x for which the function is defined. The function is real also, you can say. It is giving real output. So as you can see here, that here the domain of this actually is real number, because for all the values of x you will find some output, like 2 square is 4, 3 square is 9, 3.5 square you will calculate and it will give you some value. You will increase the value of x, you will get some value of x square. You will decrease the value of x, then also you will get some value of x square. So the domain is real number as the output is coming. But if you take the function y is equal to square root of x when x is greater than equal to 0. So we saw this graph earlier in previous slide, that this is the graph of y is equal to square root of x. The upper part of y square is equal to x. If it is asked what is its domain, so what you will say clearly, for negative value of x, for negative value of x there is no output, because the square root of negative number is actually not real. For example, square root of minus 2, it is not real, because no real number will square to give you minus 2. If you say that root over minus 2 is real, suppose a, what does it mean? That minus 2 is equal to a square. But any real number on squaring does not give you a negative number. So on squaring you can't get minus 2. So that is why this is not real. So if it is not real, then for negative values of x you can't get any output. There will be output for positive values of x or for 0. So you will say that its domain will be x belonging to 0 to infinity, where 0 is included and infinity is excluded. So till here we have studied few things. One thing is the definition of function. What is the definition of function? Each element of set A is uniquely mapped to set B. What is the graphical method of finding out that whether it is a function or not? So we will draw a line parallel to y axis, and if it cuts the graph at only one point at all places, then it is a function. But if it cut it more than one place at any point, then it is not a function. Next, we studied some type of functions like y is equal to x square and y square is equal to x, where we studied that y is equal to x square is a function which is a upward opening parabola, and y square is equal to x is not a function, but you can make two different functions, y is equal to square root of x and y is equal to minus square root of x out of this given relationship. Then there is a domain. Domain is the values of x for which the function is giving you the real output. So, you have to decide what values of x you can take. For example, we can take some other situation also. If it is written a function fx is equal to 1 by x, what will be its domain? Can you tell me what will be its domain? So, of course, its domain will be such that it should not be not defined or not real. So, if you take any value of x other than 0, it will be giving you some real output, but at 0 it will be a problem, because when you take 0 at the denominator, then 1 by 0 is not defined. 1 by 0 is not defined. So, you have to eliminate 0 here. So, what you will say that the domain is x belonging to real number except 0. So, this will be its domain. If you talk about a function fx is equal to 1 by square root of x, then what would happen? Then there is a square root of x. Then two conditions are there. First, there should not be a negative value because it is a square root. Next, since it is a reciprocal, 0 should also not be there. So, the domain would be x belonging to 0 to infinity, and just try to understand the difference between this domain and the previous domain. The previous domain where we talk about 0 to infinity, there we included 0. Why? By taking a square bracket, because it is not in the denominator, it is in the numerator. So, root over x can give you x is equal to 0 as y is equal to 0 also. And if you take 0 to infinity where 0 is not included, then it is the domain of this one, because here you cannot take x is equal to 0 as it is in the reciprocal. So, this is how you have to decide whether it is a function or not and what is its domain. For example, if I give you fx is equal to square root of 2 minus x and I ask you how to find the domain of this, then what would you do? You will simply say that 2 minus x over here is greater than equal to 0, then only the function would be defined. The input should be greater than equal to 0, which means 2 is greater than equal to x, which means x is less than equal to 2. So, x should be less than equal to 2, that means x belonging to minus infinity comma 2, which is closed like this. Now, we come to one more function y is equal to x cube. This function, when you will draw the graph, would be something like this. This is y is equal to x cube, and when you draw this graph, you will see that this is a function obviously, because for any line parallel to y axis, it is cutting it only at one point, and as you can see that its domain is real number. So, this is also a algebraic function. X square is also algebraic function, x cube is also algebraic function. Actually, these are all part of polynomial functions. So, polynomial specific cases are these. Now, we can take some rational function also, as we have taken a little while ago, that y is equal to 1 by x. When you will draw the graph of this one, what you will see that the graph would be something like this. You can take some simple points and plot them, like you will take x is equal to 1, you will get 1, you will take x is equal to 2, you will get half, like this. If you take x is equal to half, you will get 2, like this. So, graph would be something like this. If you take negative values of x, the graph would be similar, but it would be in the third quadrant. So, this is a function and its domain, as we already studied, is real number except 0. So, polynomial functions we have taken care of 2, 1. Polynomial functions are many, infinite they can be. So, here we studied x square, x cube and saw the graph of them and their domain. And if we talk about the rational function, so rational function which we have taken here is 1 by x, and as we can see, we have seen the graph as well as its domain. Now, there is a constant function also. So, what happens in a constant function, that if you take a line parallel to x-axis at some distance, suppose 5, then it would be y is equal to 5. It is constant. That is why it is called constant function. So, in constant function, what we do is we see the graph and we can say that the output is always fixed, but the input varies. So, what is the domain? Domain is real number, all real numbers. For all the inputs you will get the same output, and which is 5, nothing else. So, you can't get different outputs. So, domain is real number and output is same, which is 5, which is called range, but we are not going into the concept of range right now, but there is something called range also, which gives you the output, the value of y. So, this is a function which is a constant function. This is also a polynomial function, x to the power 0 into 5 we have taken here. Now, if we talk about another function, suppose we talk about a function which is, suppose a mod function, y is equal to mod of x. So, modulus function is a very important function, and modulus function or absolute value function, what we call it as, is very important to understand. Actually, when you take mod of any quantity, like you take mod of -3, you will get 3, and you take mod of 3, you will get 3. That means it absorbs the minus sign, and if it is positive, then it will give you the number as it is. So, the modulus will give you the positive output, that is the absolute value. That is why it is called absolute value function. So, if you take mod of x and draw its graph, what would happen? That graph would be something like this, that if you take 3, you will of course get 3, but when you will take -3, what would you get? Again 3. For 2 you will get 2, for -2 also you will get 2, and for 0, 0 mod is 0. So, this is a curve which is like this, two straight lines are there. This is a V-shaped graph. So, two straight lines are there, and these two straight lines will give you the graph of y is equal to mod of x, and they are intersecting at origin. So, if we talk about its domain, that domain is real number here, and all the values will give you some output, and it is a function because any line which is parallel to y axis will intersect it only once at any input. So, this is obviously a function. So, these are some of the basic and conceptual functions which we have to study. There are many other functions like greatest integer function, fractional part functions, and many other type of functions in step functions which we need to study sometimes. So, be with us always and try to learn new concepts, and always go for our Cube Live and always see the new concepts there and join our classes. Thank you, students.